Right then, hi all. Thought it was about time I gave you an update of what I've been up to with the Hunter build. Basically it's been quite slow, work's been crazy at the moment, so I haven't been able to spend very much time on the Hunter. But what I have been doing is with the Form 1, when I haven't been using for work, I've been doing some rotors and doing some parts for the EDF unit for the Hawker Hunter. So basically I thought I might just show you firstly a bit of a workflow or show and tell of the development of the rotor based on SLA printing rather than the FFF printing, the standard MakerBot or whatever filament based printing. So as you know, some of you probably know, I've had the Form 1 for a couple of weeks now. I've had some problems with it, so it's actually gone back to be repaired hopefully. But in the meantime, while it's away, I finished up a rotor, a 6-blade rotor, and part 2 of this I'll actually test the 6-blade rotor on 2, 3 and 4 cells and see how it compares to the other rotors I've been doing with the filament based printers. So it's not going to be like for like because I've actually changed the jig for the printer. So I've changed the jig or the EDF test rig. What you can do with the Form 1 is you can print a clear plastic. A clear resin, and if you sand it and finish it with a clear coat of acrylic, you get a really transparent part, which I thought would be great for the test rig, so I can actually see the rotor, see the motor, I can see everything inside the rig now, rather than it being hidden. I mean, previously this is what I was using, and this is the filament based rig, rather than the SLA printed rig. So without further ado, I'm going to zoom in and just have a chat about some of the bits I've been doing. Okay then. Right then, so the first thing I printed on the Form 1 when it arrived was a shroud, and all I did was I took the file, the STL that I used to print the equivalent in a filament based printer, FFF type based printer, the modified MakerBot, and I just printed it straight in on the Form 1 just to get a like for like comparison. So immediately first impressions was, you know, wow, hell. It's printed at 0.5 millimeter layer height, sorry, 0.05 millimeter layer height. And you can still see the layers in there, but it's very smooth. The detail on the for the fittings of the motor mounts where the screws go and the cooling holes, absolutely brilliant. I've got a true aerofoil section on the stators now. Lovely little details where I put a little sorry, let's try to get you in focus. A little lip coming around where the cables come out of the motor. The mountings, I mean, everything turned out great. The trailing edge was a little bit thin, so actually that was the only thing I did change on the STL was the actual stators. So with the filament based printer, they were about 1 layer thickness, so 0.35 millimeters thick, these stators, and then I sanded them down. I sanded the trailing edge down, so they were really fine. With the Form 1, obviously you don't have to really do that much sanding on it. It just comes off and it's, you know, it's almost there at point. I think I took that down to nothing, and it actually failed a little bit on the one stator. Hopefully you can see in there on this stator over here, this top one. You can just see where it's failed a little bit. So So immediate thoughts were, wow, you know, feels stiffer than the ABS plastic one I've printed with the filament, and stronger as well. Stronger in the sense that it doesn't delaminate. You can see on this one here, it started to delaminate where the layers are, and you're going to have that with ABS. That's the weakest point, is where the layer heights are. This was printed at 0.1 millimeters, and then sanded, acetone bathed, etc, etc. This is as it came out the print. All I've done is just broken off the supports and just tidied it up so there wasn't no sharp bits. So after that one, I moved on and I printed another variation on that, just to give it a little bit more strength. So I put like a ribbing in there. So this is a thing you can do with SLA printing. Yeah, you can do really delicate, fine detail. So I put some ribbing on that area, just to give it a little bit more stiffness. What else did I do? I corrected the trailing edge on these. So, you know, I think the trailing edges are working at 1/4 mil now, thickness. So 0.25 millimeters. And that came out great. The only problem was I didn't quite orientate the model right, and I had problems on the top. A lot of the learning with the SLA was just orientating the model in the slicing software preform, and I think, you know, a lot of that is a little bit of black magic plus experience really. So I'm getting better at it. So the next one I printed was this one here, and this one was, you know, a good working prototype. I don't think there's any issues on this one, apart from I slightly cracked it because I was too rough with it. I think I stood on it, and I had some clouding issues with the resin. So again, that might be just not post finishing the part correctly. Either I didn't wash it in the alcohol and clean it enough, I think. And then moving on, I then decided to try at the rotors. So that was probably the first week I had the printer. I was doing these trials, and there's loads of them. There's loads of different, you know, I just picked up some examples, but I got a whole bag of partly printed failed prints, etc. So the next thing I thought I'd have a go was the rotor. So I redesigned the rotor because I knew I could actually put a correct aerofoil on the rotor now. With the filament ABS printed models, I couldn't put a aerofoil, a true aerofoil on there. So I saw the rotors are like blanks. Got an example over here. Yeah, there we go. You can see that it's like a blank. So I've got some curve, some aerofoil curve on there. And what I had to do then is sand the aerofoil on there if I wanted the aerofoil on the actual rotor, on the blades. So, you know, I've got a 9-blade rotor there, so there's quite a bit of sanding and finishing, post-finishing on the ABS printed rotors. So, obviously I redesigned it, and then I printed it as if I was printing it on a with the filament-based printers, the ABS FFF type printer, and with the SLA based printers, you need to always print it on support. You can't sort of print it straight onto the build plate. It sort of prints upside down. So I printed horizontally because that, you know, I looked at it and went, oh, that's how it needs to be printed, and it came out okay. The trailing edge was a little bit thin on the rotors, so it sort of failed over here. But the detail it picked up was great. The aerofoil, like a true aerofoil on every single blade, is already there. So there was very little, I expect very little sanding to be done, or post work to be done on that. So, and the other big problem I had was on the leading edge, or the leading face of the rotor. I've got a pretty poor surface really, and it's just the way I've basically orientated that on the print on the build plate. So again, big learning curve, just orientating these models, how to orientate the models. There's lots of help and support on the Form 1 website. So just go, I mean, if you go to Form 1, just go on there and have a look. The forum's great as well. So there's people on there that actually help you and sort you out. But I think a lot of this is just going to be trial and error and a learning curve. And I think certain types of print will, certain types of parts or part geometry will print better in certain orientations on the build plate. So so after that first print, then I decided, well, you know, let's not print the whole rotor, let's print just a blade, and just work on the blade and see how far I can push the blade, i.e. the trailing edge, how thin I could get the trailing edge. So I think I started at 0.1 millimeters for the trailing edge, and I went up in small steps, and I got to 0.25, which I said earlier, and I've got a nice clean trailing edge printing. So again, it's, you know, just seeing what I can get away with. I think in their specifications they say that the smallest resolution you can print is 0.3 millimeters, but like I said, that trailing edge is 0.25, so I'm getting away with it, and it's coming out great. So once I was printing these reliably, I then wanted to see the difference in print quality. So I printed three blades, exactly the same file, just at the different print quality. So I started at 0.1 millimeters, and it came out brilliantly. You know what I mean? If that came with the printing 0.1 on the MakerBot, actually this one's had some work on it, so it's not really a fair comparison. This is just off the printer, and this has had some work done on it already, cleaned up a little bit already, and this is 0.1 and this is 0.1, and they're miles apart. The quality on the SLA Form 1 print is really, really good, and you got a perfect aerofoil printed, you know. So at 0.1 came out great, so I went to 0.5 to see what the difference is. I don't think I actually cleaned this one correctly, but you can see a difference. Yeah, it's slightly smoother. It obviously taking twice as long to print that. Right, so the next one was 0.025 millimeter, which is the finest layer height you can print on the Form 1. And again, you know, unless you look really, really close, it's definitely printed smoother. It's taken 4 times as long, don't know, than the 0.1 millimeter. So 0.05 for the rotors is more than adequate, and I'll probably start printing them at 0.1 because the quality is just so much better. And if I were to run some wet and dry paper over that, that would be smooth as a baby's bum, basically. So so I've established a good feel for print quality, reference to the layer heights. So once we'd finished that, I then printed the rotors, and I've actually got one in the rig at the moment, which is the one we'll be testing. Oops. Hopefully you can see it in there. So this is the first one up for testing. So I'll run that up in the second part of the video. So this is the orientation I found that works best for the rotors. Prints really well, and as you can see, it's still attached to the supports. Whoops, get in a bit. There you go. Still attached to the supports, and it's absolutely brilliant. I mean, the quality on that is absolutely brilliant. And again, I'll take some close-ups, but hopefully you can see the aerofoil has been reproduced perfectly on every blade. Basically, it's very, very reliable. So I've just highlighted it. So that's basically off the build plate with no cleaning, and then that's what I was doing with the MakerBot, the filament based printing. So you can see the difference. You know, this has had a little bit of work done to it, just tidied up slightly, but I haven't sanded the profiles onto the rotors yet. But as you can see with the Form 1, I've got that aerofoil reproduced perfectly. So the sweep works really well. So it just opens up so many new avenues from a design perspective. So moving forward from that, I then finished them. So I've done a clear one because I thought it'd be cool. This is when the printer started playing up. I think there's a problem with the laser. you'd probably see some bubbles and stuff in one of the blades, and I think basically the layers are sort of a little bit diffused, so as it's part curing some of the resin in the resin tank, and then obviously that's getting caught up in further on down the print, and I'm getting a lot of jelly in the sort of part cured resin inside the build tank as well. That's why it's gone back to hopefully get that sorted. So again, I will take some macros of these so you can see. There's the aerofoil reproduced perfectly. On this one I wet and dried from probably 800 grit down to 2000 grit. I took probably half an hour getting this one just standing. I just want to see how far I could actually push the surface finish on it, but I think it hasn't come as good as it could have done because of the problems with the printer, the actual physical problems with the printer. So although it's brilliant and it's more than adequate as a rotor, I'm sure when I get the printer back it's going to actually be a lot better. So, and then once I've done that, then I gave it a clear coat of acrylic, very much like I did with the ABS molds. Let that go off and dry. Then I got a cutting compound and just polished it up, and you know, I'd say no more than half an hour to get from that to that. And I don't even honestly know whether the time spent polishing the surface and finishing the surface is going to be reflected in the final performance of the rotor. So that'll be a test I do. I'll do one that's printed straight off the printer with no post finishing on it, and then one that's been polished. It's probably the same rotor but just polished, and we can have a look at and see if there's any significant performance benefit. It's always good to know where to spend your time with these things. Okay, so basically that's, and then again, this is an example of a rotor that I finished, a filament based rotor that's actually finished, and that's one of the rotors I test with. It's a 9 blade, and this has taken a good 2.5 hours, perhaps 3 hours to finish, because I had to sand the aerofoil on every single one of these rotors. And obviously, you know, no matter how much care you take, you're never going to get perfect. And if you have a look at the two, hopefully you can see that. You can see the grey one is significantly better, and more importantly, but that same profile is reproduced on every single one of those blades. So yeah, so definitely for this sort of thing at the moment, SLA's way to go. I'm still using the Form 1 V1 grey resins. So it's the first, they've actually brought out a version 2 of the grey and the clear that's supposed to be significantly stronger. So I'll get through the V1 and learn as much as I can with that, with the knowledge that coming the V2 they're going to be a lot stronger. And I mean, you know, you can see that there's absolutely no flex in these blades. They're so stiff, but they are quite brittle compared to the ABS. So stiffness is good, but obviously if that touches the shroud as it's spinning around, it's going to disintegrate. So I'm looking forward to actually trying the V2 resins when I get my hands on them. And then finally, like I mentioned just briefly earlier on, I've looked at with the clear resin, you can actually finish it up so it becomes very, very transparent. This is one of the failed prints because there's a lot of gunk and stuff getting caught up, because I think it's because of the laser in the print. So I still finished it, and again I just wet and dried that down to from 800 down to I think 1200 on this one, and it came out fine. You know, it came out great. And, you know, as you can see on the test rig here, I can see right into the rig. So I'm quite excited about having a clear like this, especially when it's in the model. So you know, if you're worried about your rotor being chipped and whatnot, hopefully you'll be able to see through the clear shroud into there without stripping the whole thing out the plane, the model. So yeah, I'm pretty excited about sort of applications we can use this clear resin with. Another thing would be really good would be to use it for the core part of the molds, so I can actually see what's happening with as the foam expands, the urethane foam expands. I can actually see where it's going. So I won't be doing the casting blind anymore with the molded, with the urethane molds. Probably not explain that very well. So we have the wing mold that you've probably all seen. So what I'm saying is, what we do is, all I can do is I can print this one in the clear, the cavity, sorry, the core part in clear. And so when I pour the urethane in there and clamp it all up, I'll be able to see through the core bit and see where the urethane's moving. So hopefully it'll give me a little bit more of an advantage when I'm casting, or better understanding rather, when I'm casting with the urethane foams. So I'm really excited about that as well. Right then, so enough waffling. I'm going to hook everything up, get the computer all set up, and we'll run through and test the rotor and see how it performs. I'm sure it's going to be fine. Sounds lovely. I've just tested it in my hand, just run it up in my hand, and sounds very, very smooth. Lovely sound coming from it. So hopefully we won't have bits of plastic flying everywhere. Okay, I'll see you in a bit then. Cheers.